Hello everyone, welcome back to the channel. So in today's video, we are going to discuss about the ladder friction. So it is a part of friction module, and in the friction module, we have covered the horizontal plane friction, then the inclined plane, and this is the next part. So don't worry, this will not be asked in the final exam, but you should have an understanding of ladder friction. That's why we are making this video. So in ladder friction, with the condition of equilibrium, we generally take summation fx0, summation fy0, we consider it as a concurrent force system in the friction, but in the ladder friction, we have to consider the moment as well. So let us start. But before starting the question, I will request you to watch this video till the end and subscribe to our channel. So we'll start with the question. A ladder AB of length 3 meter and weight 25 kg is resting against a vertical wall and horizontal floor. So there is a vertical wall and a horizontal floor and a ladder is resting on it. A ladder makes an angle 50-degree with the floor. So this ladder makes an angle 50-degree with the floor. A man of weight 60 kg tries to climb the ladder. How much distance along the ladder he will be able to climb if mu between the ladder and the floor is 0.2, between ladder and the wall is 0.3. Also find the angle of ladder should mix with the horizontal such that the man climb till the top of the ladder. So this is a given question. So we'll start with the FBD. So this is the vertical wall. Then we'll draw a horizontal floor here. Okay. Then we'll draw a ladder which start from here and goes here. This way we can draw it. Now some values are given like we'll point out certain value. The mu between the ladder and the floor is 0.2. So it means that the value of coefficient of friction between the ladder and the floor is 0.2. So we'll show it there. And between the ladder and the wall is 0.2. That value is shown here. So here mu is equal to 0.3. So it will have different values of coefficient of friction for the ladder and the floor. So show them all. Then they have mentioned the weight of the ladder is 25 kg. So we'll show the weight force acting from the center of this ladder. So for that, we'll show the weight force with the help of this arrow. It is exactly passing through the center and it is vertically downward direction. Total length is 3 meters, so this is 1.5 meter and rest of the length is 1.5 meter from here to here. So this way we can show the weight force. The value of weight force is 25 kg. So here it will be 25 into 9.81. So convert this value into Newton. So show the weight force. Then we'll show the a man try to climb the ladder. His weight is given 60 kg. So we'll show a man who is trying to climb the ladder and he is able to reach this height while climbing. So his weight force is shown. Its value is equal to 60 kg. So it also acts in the downward direction and his value is equal to 60 kg. So again convert this into Newton. So 60 into 9.81 Newton. Okay, this is the value of the weight force. Now, how much distance he has climbed before the slipping that we have to calculate. So we'll consider this distance is equal to x. The angle of the ladder with the floor is 50-degree. Now, these are the given data that we have put in the FBD format for this ladder friction, right? So weight force of the ladder is shown, weight force of the person is shown, then the coefficient of friction is shown. Now see when the ladder slips because of this person is climbing on this ladder. So how it will slip? So initially ladder is at this position. So because of the weight acting on it, this will slip like this. Means the upper end will move downward and this end will move towards the left side. Getting? So this is the movement of the ladder when it slips. So this end here it will move down. So friction force will act opposite to the motion. So this will act in this direction. So this is the direction of the friction force. Also this end will slip to this side. So the friction force will act opposite to that. So this will act in this direction, right? Then we'll draw the normal reaction. So it is towards this point. So normal reaction will act in this direction. Same way here, normal reaction will act in this direction. Okay, this is point N1. So the friction force become coefficient of friction here is 0.2 N1. Then we'll consider this is N2 reaction, and this friction force will become 0.3 N2. This way we can draw the FBD or complete the FBD for the ladder friction. Always consider or imagine the direction of the ladder fall, and as per that you have to show the directions of the friction and the normal reaction. Now with this FBD we can start by applying conditions of equilibrium. Okay, so here we can apply conditions of equilibrium. So the first condition of equilibrium is summation fx, it is equal to 0. So here the horizontal forces are 0.2 n1 is a horizontal force, but it acts in the towards right, so it is positive. Then n2 it acts to the left side. So these are only two horizontal forces. So we'll write it here. First one will start with the n1. So 0.2 n1 minus n2. So it is equal to 0. This is our first equation. Second, we'll apply summation Fy, it is equal to 0. Identify the vertical forces here. N1, 60 into 9.81, 25 into 9.81, and 0.3 N2 are the vertical forces. So out of that, this force and this force, weight force are only negative forces. These two are positive forces. We'll write it here. So first one is N1 plus N2 minus 60 into 9.81 minus 25 into 9.81. So it is equal to 0. Rearranging this equation, N1 plus N2, it is equal to 60 into 9.81 plus 25 into 9.81. This will be our equation. Now putting these two equations in the calculator, we can easily find the value of N1. So by calculating, we'll get the value of N1 is equal to 786.65 Newton, and N2 is equal to 157.33 Newton. You can calculate it. If you have any doubt, you can write it in the comment box. So this value we are getting, right? Then we'll go to the next one. We need to calculate the distance traveled by this person before this sleeping start. So for that, we should apply the third condition of equilibrium, that is summation of moment at this point A, it is equal to 0. Now for this, say N1 and 0.2 N1, these two are passing through point A. So their moment becomes 0, right? Because these two or line of action of these two is passing through A, so it becomes 0. Next force is 60. Now this weight force will rotate in a clockwise direction. So this is minus 60 into 9.81. Now what is perpendicular distance? To calculate the perpendicular distance, what we can do, we can draw a vertical line passing through this force. So this is the vertical line and same vertical line passing through A. In between them, this is the horizontal distance. This is equal to x. So this distance can be calculated by using a triangle. So for that, we'll consider this triangle from here to here, here to here. So consider this triangle. The side of this triangle is x, hypotenuse is equal to x. This angle is 50-degree and we require this distance. Okay, to calculate this distance, we can use a cos relation. So cos 50 is equal to, this side will consider this as small a. So small a divided by hypotenuse. So x is equal to a into cos 50, right? A is equal to x into cos 50. So use the distance. Distance is x into cos 50. Then this next weight force 25 into 9.81, it also act in the clockwise direction, right? Rotation of the moment is clockwise. So it is minus, we'll put minus 25 into 9.81 into perpendicular distance. Same way we have to consider the next triangle here. So for this the length is 1.5 and this triangle will look like this. Okay, we'll draw it here. This is the next triangle. This is 1.5. This is 50 degree and this is the required perpendicular distance. So again use the cos relation. Cos 50 is equal to adjacent side divided by hypotenuse 1.5. So B is equal to 1.5 into cos 50. So that comes here 1.5 into cos 50. This is the next equation. Next one we'll consider N2. About point 8 this N2 rotate in a anti-clockwise direction. So it will make a positive movement. Same with this 0.3 N2 will create a anti-clockwise movement. Okay. Now to find out the perpendicular distance, draw a horizontal line from A and draw a horizontal line from N2. So this distance will be the perpendicular distance for the N2. I will draw it here. So distance from this point N2 to this one. This is the perpendicular distance for the N2 and for this 0.3 N2 perpendicular distance will be here to here. This is the perpendicular distance for the 0.3 and 2. So to find out this distance, hypotenuse of this triangle will be 3 meters. So we'll draw it here. Okay, this angle is 50. This side is 3 meter. This is side A. This is side B. And here we have got this force N2 and this is the upward force 0.3 N2. Just check it is 0.3 N2, right? So for the N2, the moment is plus N2 into perpendicular distance. Now to calculate the perpendicular distance, we require this distance A. So we'll use the sine 50 relation. So sine 50 is equal to opposite to the 50 is A divided by hypotenuse. So A is equal to 3 into sine 50 plus next force is 0.3 N2 into. Now for this 0.3 into perpendicular distance is B. So we'll use the cos relation here. So cos 50 is equal to adjacent side divided by hypotenuse. So 3 into cos 50. Now this total equation is equal to 0. So equate it to the 0 and find the value of x. So you can write the value of x in the comment box if you understand how you can take the moment. So as per my calculation, x comes out to be 0.5712 and this is the distance, so we can write the unit as meter. So this way you can take the moment for the given FBD. So calculation of the distance for this weight force and weight force of the ladder becomes little bit difficult, as well as the distance for N2 and 0.3 N2s are not given. So that's why taking moment is little bit difficult in the ladder friction. As well as they have asked one more thing, that what angle it should make with the horizontal such that the man climb till the top of the ladder. So this is the second part of this numerical. So again we'll draw the ladder here. Basically this is the floor and this is the wall, right? A ladder is kept on this floor and this one. Okay, the given values are 0.2 and 0.3. So we'll write it here. This value here it is 0.2 and for here it is 0.3. Now the man moves upward without sleeping. He has reached this point. This is normal here and this one is here. Friction force, ladder moves in this direction, so friction force opposite to that. Ladder moves, this end moves downward, so friction force opposite to that. So this is the weight force of ladder, and the man climbs here till the top of the ladder. This is 0.2 N1. This is point A. This is the weight force of the ladder. So 25 into 9.81. This is N2 and 0.3 N2. Now values of N1, N2 is already calculated. It won't going to change. If you want, you can check that value. Here we'll take the last condition of equilibrium, that is summation of moment at A is equal to 0. We'll use it and try to find the answer. Okay. So first, starting with A, these two become 0, right? As they are passing through point A. Next one is 25 into 9.81. This angle is theta. This is the required angle. So we'll start with first one. This weight force will create a clockwise moment about point A. So we'll write here 25 minus 25 into 9.81 into perpendicular distance. To calculate the perpendicular distance, consider this triangle here. So this triangle here is like this. This is the vertical line, this is the horizontal line, and this is the hypotenuse. So this is the half of the length because weight force acts at the midpoint of this ladder. So this is angle theta, and this is the required distance A, which is perpendicular distance. So cos theta is equal to, it is equal to adjacent divided by hypotenuse. So A divided by 1.5. So A here is 1.5 into cos theta. Okay, then we'll consider the P distance. So this P person is moving in the downward direction whose weight is 25 Newton. So it will also create a clockwise moment. So its value will be minus 60. The weight of person is 60, not 25, into 9.81. Into, now consider this triangle, big triangle here. This is a triangle. This value is theta. This is side A, this is side B. To get this side A, we can use the cos theta relation. Cos theta is equal to A divided by hypotenuse of this is equal to length of ladder, that is 3, and sin theta is equal to opposite B divided by 3. So for this side or for this force, this is the force acting here. So this will be the perpendicular distance for the weight force, right? So this is equal to side A. So side A is equal to 3 into cos theta. So we'll use that 3 into cos theta. The next force is 0.3 N2. So it will rotate in an anti-clockwise direction. So it will be positive. So plus 0.3 N2. N2 value is already calculated into. Now this vertical force and this point. So this will be the perpendicular distance between them, that is equal to again distance A. So this distance A is equal to 3 into cos theta. Okay, then this N2. Again this N2 will rotate in a anti-clockwise way around A. So it is positive. So plus N2. Now the perpendicular distance here is, draw one horizontal line from here. Draw one line, horizontal line from here. So this is the perpendicular distance between them. So that is equal to distance B. So B is equal to 3 into sin theta. So it is equal to 0. This way we can write the equation. Now keep the cos term to one side. So this is equal to cos theta is equal to minus 25 into 9.81, then into 1.5, then this minus 60 into 9.81 into 3, then plus 0.3 into N2 into 3. So this complete cos theta. Then take this term to the right side. So minus N2 into 3 into sin theta. So here we can find out sin theta by cos theta relation. So for that, take this cos theta to the right side. So it becomes sin theta, which is already there, divided by cos theta. So sin theta by cos theta becomes tan theta. So here we get on the left side. So previously it is from minus 25 into 9.81 into 1.5 minus 60 into 9.81 into 3 plus 0.3 into value of N2 is 157.33 divided by minus N2 157.33 into 0.3 into 3. Sorry, not 0.3. We'll delete it. So it is 150 minus 157 into 3. So this will give you the value of tan theta, and theta is equal to tan inverse of this complete bracket here. So you can find the tan inverse of this answer, this calculation, you will get the value of theta. So you can write it in the comment box what you are getting the value of theta. So theta is equal to, as per my calculation, 76.67 degree. Okay, I hope you understand this question. Slightly difficult, only taking moment and drawing the ABD makes this problem very complicated. But if you understood it, you can easily solve this question. If you have any doubt, you can write it in the comment box. If you find this video helpful, you can like our video, you can subscribe to our channel, and you can share this video with your friends so they can understand the ladder friction. Thank you very much.